Astronomers have detected X-rays from Uranus for the first time using NASA's Chandra X-ray Observatory. This result may help scientists learn more about this enigmatic ice giant planet in our solar system. Uranus is the seventh planet from the Sun and has two sets of rings around its equator. The planet, which has 4 times the diameter of Earth, strangely rotates on its side, making it different from all other planets in the solar system. With Voyager 2 as the only spacecraft to ever fly by Uranus, astronomers rely on telescopes closer to Earth, like the Hubble Space Telescope, to learn about this distant and cold planet that is made up almost entirely of hydrogen and helium. To learn more about Uranus, researchers used Chandra to observe the planet in 2002 and then again in 2017. They saw a clear detection of X-rays from the first observation, which was just analyzed recently, and a possible flare of X-rays in those obtained 15 years later. What could cause Uranus to emit X-rays? The answer, mainly the Sun. Astronomers have observed that both Jupiter and Saturn scatter X-ray light given off by the Sun. Similar to how Earth's atmosphere scatters the Sun's light and turns our clear daytime skies blue. While the authors of the new Uranus study initially expected that most of the X-rays detected would also be from scattering, there are tantalizing hints that at least one other source of X-rays is present. If further observations confirm this, it could have intriguing implications for Uranus. One possibility is that the rings of Uranus produce more X-rays than the rest of the planet, which is the case for Saturn's rings. Uranus strangely has a high number of very energetic particles in the space environment around it. If these energetic particles collide with the rings, they will cause the rings to glow in X-rays at wavelengths that depend on what the rings are made of. Another potential explanation is that at least some of the X-rays come from auroras on Uranus, a phenomenon that has previously been observed on this planet at other wavelengths. Uranus is an especially interesting target for X-ray observations because of the unusual orientations of its spin axis and its magnetic field. While the rotation and magnetic field axes of the other planets of the solar system are almost perpendicular to the plane of their orbit, Uranus is the only planet whose rotation axis is nearly parallel to its path around the Sun. The axis of its magnetic field is also offset by an unusually large angle from its spin axis. This may also result in auroras on Uranus that are unusually complex and variable at different wavelengths. Determining the true source or sources of the X-rays from Uranus could help astronomers better understand how more exotic objects in space emit X-rays.